Howdy, everybody. My name is. Oh, let's start that over again. Howdy, everybody. My name is Dan Saul, and I am here to talk about Git. So, how are we going to do this? Well, I feel the best way to learn, especially when it comes to Git, is just to have recipes on how to do things. When you're working with Git, which you will be working with a lot, or at least some kind of version control system, you don't really need to know everything. But you will encounter stuff that causes you problems, and you'll need to look that stuff up at that time. And that's kind of how everybody does it. You encounter a problem, you stick it into your favorite search engine, and you follow whatever instructions are there. So you don't really need to have a super in-depth knowledge, but knowing what to ask for is very helpful. So how will I do this? Well, I'll do it with cookbooks and recipes. Now, at one point, I counted 24 different recipes that I wrote. That was pretty early on in me writing this. Might be different at this point, so I put a plus symbol. I don't really want to count it again. I will go on tangents, and I will talk about history wherever it's relevant. And, well, if you're listening to this specific one, it's recorded for later reference. Every 30 minutes, when I'm presenting this in person, we are going to have a pause. This is primarily because the camera that I'll be using has a 30-minute recording limit. And at least in this recorded one, we're going to go through everything. So, what is Git? Git is a version control system. Well, that's not very helpful. What is a version control system? Well, when you're working with source code, or really anything that has things where you work on things over a period of time, you can end up at times when you have good checkpoints or places where you can stop where you have a complete product or complete item, whatever it might be. And it'd be good to be able to save that so you can reference it later or go back if something didn't work out. And that's what this is. It controls different versions, the steps through everything. Additionally, Git helps everybody work together. So because everybody's working on their own copies of everything, you're not uploading files. Files might have changes in different places, but from different people. This can cause issues. And Git helps bring those all together. And as I said earlier, it's basically save points if you're going with the whole like gaming metaphor. Now, there are a few assumptions that I'm making when making this presentation and also other reference material. And that is that you know computers. So the basics, you gotta know what a file is, you gotta know what a directory is. Because this is programming and it requires the command line, well, you need to know that. Um, you can follow along basically, but you might get a bit lost. Don't let that stop you, but anything that you're missing, you should surely look up later. Also, you need to know what local and remote means. So, I mean, local is here on this current computer, remote is somebody else's computer. There are more implications that I won't go into, but for the most part, that's what that refers to. So, when I talked about making this presentation, I started off with just these slides. And then I realized that I was going way more in depth than was useful for people that are starting out. But the information's still useful. So I made a book. Yeah, spent way too much time on that, but regardless, I made a book and it is good for a reference. So as much as the slides are good, the book I wrote is much better than that. So you have a QR code here if you want to scan that. You can also check it out when I post it later on Discord. But regardless, check that out. So, why do you want to use Git? Well, be selfish. Now, what do I mean by that? So, you want to save stuff and have a trail of changes that you can look back to when you look at your project in 6 months. Because unless you are extremely intelligent not even intelligent, but can remember stuff like perfectly a year, 2 years later, you want to have something to refer back to. So not only are you helping other people when you're working together, but you're helping yourself. You're helping the other person that is you in the future. So because everything is tracked, if something breaks, and this is more for an industry thing, but you'll know who to blame, or rather, who to ask, why did you do this? If something breaks, well, if things are done properly with discrete changes, you can resolve regressions, revert stuff. It's very nice to have. So I am going to point out the pink elephant, and that is a lot of people will use graphical interfaces to work with Git, and that's fine. I do it too. But if you don't actually know how things are working under the hood, well, you can't fix things, or at least you can't fix something that you're not following instructions for or have dealt with prior. But if you understand how things are put together, you can use that knowledge to come up with solutions. So yeah, as the slide says, if you use graphical interfaces before the command line, it's a crutch. You need to learn the basics. So, you say you don't know what Git is. You need to install it. Well, I'm not going to tell you how to do that. Any instructions I provide, not really relevant to your specific computer. It would work on mine, but apart from a few people in here that are super into Linux, you probably don't know NixOS. So rather than give you instructions that are not going to be relevant for you, I've put up 3 different documents here that will tell you how to install Git. And presumably, because these are all relevant to people who have stake in Git, these will be updated over time. So follow these instructions instead. Now, we'll start from the basics. You installed Git. Now what do you do? Well, there's a few things that are mandatory configuration that you have to do, and a few that are not mandatory, but I like them. So, what are these? Well, you have to set your name. And these are just terminal commands. You can either set it for your specific project, or you can set up for every project. Just set it up for every project. So you first set your username, and then you set your email. Now I prefer to use Rebase for everything. I haven't talked about Rebase yet. But I would set this setting here, which changes from merges to Rebase. So essentially, the very short explanation as to what merging and rebase is merging is when you bring 2 different branches together at one point, and all the changes are brought in, and it can be fine, but it can be more work. I found that rebasing, which is you go back to the point where your branch and diverged from the main one, and then replay the changes on what you're bringing in. And I found that this works so much better with less conflicts. It's not perfect, but nothing is. Finally, this is more of a personal thing. I like having colors in the terminal, so I turn them on. So let's go through this. So you can see here, I'm typing the configuration commands. So the first one should be the username. The second one should be the email address. Now we're turning on rebasing. And finally, terminal colors. All done. That was pretty easy. So now that you've set up Git, you'll want to create a repository. Chances are you already have a project and you're like, I should really track this stuff now. So how do we do that? Well, we go into the folder that we want to make a repository. We type git init, which will create an empty repository. Then we check out a new branch in this case using git checkout -b trunk. Then we add our files. So one thing of note is that visible files as well as invisible files need to be added separately. And then we commit these changes to our repository with a message. Now, the first one's usually something simple like initial, first, something like that. But it's always good to have it, at least in professional environments, to be more descriptive. So let's go through these. So we're going to create a new folder. We create a repository. We check out a new branch. We make a file in this case to commit, or add rather. We add the file. We add invisible files, which shouldn't exist in this one. And then we commit it to the repository. Very straightforward. Now, one thing of note is that this repository is not actually located anywhere. It's only on your computer, so it's not safe, let's say. But we'll get into that. So now, say you want to download a repository that's on the internet. Somebody else worked on something, and you want to make a change, or even just look at it. You want to clone that repository. So how do you do that? Well, it's pretty straightforward. You just type git clone, the link to the repository. In this case, the one that I provided here was using HTTP. But if it was something that you were doing or something that doesn't have public access, you would want to use SSH. Now, while SSH keys can have passwords associated with them, they don't always, and it can be easier. So one thing to point out is that if you put a space after the link, or the URI rather, and then put a different name there, that's what it will appear as on your computer. So it doesn't have to be exactly one-to-one with what the other person has entered. So yeah, let's go through this. Yeah. So without anything here, I'm opening up the terminal, and I'm going to clone a repository. I'm just copy and pasting it here for simplicity. There we go. And it's downloaded. Beauty. Okay. So remember before how we created a Git repository, but we didn't specify a remote server. Now, why would we want to do this? Well, you'd want to make sure that whatever you create is stored somewhere. Now, there is something about 3-2-1 backup strategy, which is essential, but at the very minimum, having a second copy somewhere else is good. You want to have more than one copy of your source code. You don't want your projects to die because they disappeared. All right. So how do you do this? Well, it's one command. You see two here, but it just depends on what type of URI you're using. So the first one, the top one, the recommended way, is to use SSH. So you just add a command that says git remote add origin, and then the link to your repository. As I said, this can be SSH, or as seen below, you have HTTP. So yeah, use SSH. You can have more than one remote, but like I posted on the slide here, I've never seen it in practice. Generally speaking, if you want to have more than one place storing your stuff, you would use your forge. So what I personally do is most of my code is stored on a Gitea instance on one of my servers. And then for the specific ones where I have them as being public, this forge is set to automatically push those changes to a different forge. For this specific lecture, it is using Codeberg, but that could be GitHub, GitLab, SourceHut. There's a whole bunch of them. So let's take a look at this. Yeah, so you go into your repository, you open a terminal, and yeah, you just type git remote add origin, and then the link to your server. All done. All right, so now that you have a repository set up with a remote, let's add some files to it. So there's a few different ways to add files. You can add a single file, in which case it's just git add and then the file name. And then you can do things that use what's called a glob. And a glob is just a way to select files using patterns. It's kind of similar to regex, but not exactly. So yeah, you can do all visible files, so git add and then asterisk. And then you can add all invisible files with git add dot asterisk. Because yeah, in Unix, anything that starts with a period is invisible. So even though that the files are now added to the Git repository, it's staging. So it still needs to be committed to be made finalized. Okay, so let's take a look at how to add files. I'm just going to create a regular file here. Now let's add this file. Now if I refresh the file here, it should eventually show a little plus symbol. Let's add another file. Yep, so we refreshed and we see that it now shows a plus symbol. The second one, of course, we were adding more than one at a single time. And finally, here's an invisible file. As you can see, just adding the asterisk doesn't add the invisible files. That's why you have to explicitly put the dot star there. In this case, it also added git ignore, but we haven't got there yet. Okay, so moving files. Now, you might assume that moving files was simple. But Git by itself doesn't really have the concept of moving a file. It does have a command for it, but what it's actually doing is it's deleting the file and it's adding the file under the new name. But the command does do it both at the same time and ensures that it's done properly. So one gotcha that can happen is you can rename a file in your File Explorer or your IDE and then add that file with the changed name, and you'll think everything's fine. But if you were to then check that file out on a different computer, you would find that the file was actually duplicated with the old one still in place with the old changes and the new one that's updated under the new name. So yeah, you can just use git mv and then the source file to the destination file. So this one's very simple, but let's go through it. Yeah. So we're first going to add the file. And then we move the file. Very straightforward. So if you want to remove a file, it's very similar to moving. And if you've used Linux or Unix or the terminal in Mac, you'll see it's exactly what you expect. So it's git space rm space the file name. And same as before, you can do more than one at a time. And like anything, you have to commit your changes. Nothing is saved automatically. So take a look at this. Yep, so we got that file from before. Now let's remove it. Easy peasy. Let's do another one. Ah, yes. So one thing I should note is that if you try to remove something that's not committed, it will error on you. And that's just because Git's trying to make sure you don't lose work. You can get around that easy enough. You just have to use the cached argument. All right, so how do you remove a file but keep it? So you want it out of the repository, but you still need it for whatever. For reference, maybe it was something that should have been local, but accidentally was committed. It's easy. So it's just git rm cached and then the file name. Slightly different for directories. Very easy. Again, you have to commit everything. So let's see this in action. Yeah, so we created the file. And we removed it. Okay. So now that we've shown some basics, let's do some definitions. I know. So commits. So every change that you're making is packaged into a commit before being saved. It's going to be a whole bunch of changes, or just one. But usually you want to keep this to like one distinct note. So if you're adding, let's say, a new page to a website, a commit would only contain everything that's required for adding that one page. So it wouldn't be that just that one page, but it would be that page plus like links to that page. One distinct feature. And this allows you to have things be easily reversed if you ever have to do that. All right, so how do you commit these changes? Well, surprise, surprise, it's another command. In this case, it's just git commit space, and you have to provide a message or it'll error. So -m, and then between double quotes, whatever your message is. So even if you commit, you still have to push it to the remote server. So it's not safe until it's there. You have to have a commit message. Git will not let you do it without that. And if you're in a professional setting, you don't use WIP and don't use just like a single letter. It'll make you look super unprofessional. And yeah, like the slide says, if you ever written an email subject line that's effective, use that same thought pattern to make your messages. You're not going to put an entire like explanation in your git commit message, but if you're scanning through it, you want to be able to see what it was about. And then you might include a ticket number in your external tracking for more information. Yeah, so let's take a look at how you commit. All right, so we got to make a change that we're going to save. And we committed it. And that's all there is. Very easy. You add your changes, or remove, depending. And then you commit the commit. And like I said, this doesn't push it to the remote. You still got to do that. All right, some more definitions. So I already mentioned it earlier about merging. So you're bringing all the changes, the differences between your current branch, and that's like what you're working on right now, and the other one. You're bringing all the changes from the other one to your current one. And what this allows you to do, say somebody added a different feature, and you want to make sure that your changes are compatible with that. You would do this periodically so that later on, when you have to add your changes the other way, things work without a problem. Rebasing, as I said earlier, it's kind of the same but different. You replay all the changes and then add your changes afterwards. This can be a lot easier because you're not having to do everything all at once. And a lot of times, your changes, when added to at the end of other people's changes, won't have to be merged because it just ends up working a lot better. It's not perfect. And you can always choose which one you do based on command line arguments. Okay, so finally, or not finally, but now we want to push those changes to our remote server. And it's just a command, as expected. Git push origin trunk. Now, let's break this down a bit. So git's the command. You're pushing, and then where are you pushing to? Well, standard nomenclature is that the origin is wherever you're sending it to, because where it originated from. Then you need to push the branch that you're working on that you want to send the changes for. In this case, it's trunk. It might be a feature branch, hard to say. If you try to push something and somebody else has already done so, you will get an error. You will need to pull those changes from the remote to your local, merge them or rebase them together, and then once that is complete, then send them back. So let's watch this. Yeah, so we need to create a commit. And then we push it. All done. Okay, so say somebody else has made changes and you need to bring them in. Well, there's a few different ways, as I've alluded to. By default, it's just git pull. If you didn't follow the instructions at the start, it'll use merge strategy. If you followed my instructions, it'll use rebase. But as I said, you can choose the specific strategy just using some arguments. Now, there are times where you will have issues pulling those changes. Say you have some stuff that is staged or worked on but not added, and you try to do a pull, but you modified a file that was modified remotely. Well, Git doesn't want you to lose your changes. So you'll need to stash those changes, pull them from remote, and then pop that stash, which applies those changes back onto the current view. So let's take a look here. We go into our repository. And we pull changes. There we go. Now, as I said, sometimes you'll have to stash your changes and pop them later. So how do you do this? Yeah, so you say you get that error, or you're trying to do something else that requires like saving your stuff, but you don't want to send it because it's not finished, something like that. Yeah, so you do git stash, which makes a save file or checkpoint. Then you do some other actions, such as checking out a different branch. Then you go back to where you were, once you're done whatever that your stuff you were doing, and then you pop that stash, which brings those changes back in. So let's take a look at it. Okay, so we'll make a change that we need to stash. We add the file. We stash the change. We go to a different branch. We go back to where we were. And we pop the stash. All right, so that was the easy stuff. On to a bit more advanced. All right, so I've been saying branches a whole bunch. Well, what is it? Well, a branch is effectively a code lineage. Each branch tracks separately. And as we said, you can merge or rebase between them to move the changes around. A lot of times there are primary branches, secondary, and historic branches. Primary branches are generally called main, master, or trunk. Secondary branches can be staging, development, or feature branches. And then historic branches are like version releases, hot fixes, specific client related stuff. But I mean, it can be whatever, as long as it's organized in some fashion. All right, so you want to list the branches. Now, one thing is that by default, it only lists branches that are local to your PC. But yeah, you can just type git branch or git branch -a to see all of them, including the remote tracking branches. So let's take a look at that. There you go. We see the branches. And this should be the remote tracking ones as well. How do you create a branch? It literally is, so from your starting point, so a branch will be from wherever you're currently sitting. So you'll probably want to be on a trunk or development, something like that. But then you just type git branch and whatever your new branch name is. Once you create it, you'll have to check it out. And it won't show up to anybody else until it's sent to the origin or remote server. If somebody changes the trunk or any other branch that it's based off of, you'll not see it here. You'll have to bring those changes in. So let's see how you create a branch. Yep, so here are our current branches. We're currently in feature branch. So we type git branch new branch name, and we'll see new branch name, which is based off of feature branch. And we check it out if we want to work on it. So as we've already seen, you'll need to switch branches if you want to see different views at different points in times or different works or different features. And that is done by checking out, which, as already seen, is just git checkout and the name that you want to check out. This switches your local copy. This won't have any remote changes, it's only your view. So you'll need to run git pull to be able to see those. Oh, and one other thing is that if your local repository doesn't know about the one on the origin, you'll have to do git fetch, which gets the list of the branches. So let's take a look at that. Yeah, easy peasy. All right, so you've been working on stuff, so has your friend, but you want to bring their changes into yours. How do you do that? Well, you just either use git merge and the branch that you're trying to bring in, or git rebase and the branch you're trying to bring in. This is probably one of the most common things you'll be doing, because whenever you're creating a pull request, it always has to be up to date with the current changes that are on the system. Apart from that, it's mostly just ticket management. So let's take a look at this. Okay, so we checked out the feature branch. And we want to merge all the changes from the main branch. This automatically creates a commit. There we are. As easy as that. Now, of course, if there was conflicts in the file, you would find it would error, and you'd have to fix those conflicts. But that's a more advanced thing. All right, some advanced stuff. Now, I mentioned earlier that you don't want to create commits that have WIP or period as the commit, but you probably also want to save like points in time where you might want to be able to go back. So how do you resolve this? We seem to be pulling in two different directions. Well, for each of these distinct features that you make, you'll want to create a specific commit for those. So the first one is just the name. After that, for each step after that, you create a fix-up commit. What's a fix-up commit? Well, it refers to the other commit, and you do it in such a way that Git knows that one is related to the other. So later on, and before you push to remote, crucially before you push to remote, you can then tell Git to merge all these into one. This is how you keep each commit being one distinct change. So how do you refer to those other commits? Well, you can either use the hash, which you can get through git log or whatever website in your forge, or you can do a text-based search. They're fundamentally the same thing. Using a text-based search is more dirty because it'll end up with like tons of like fix-up things and messages. But provided you remember to squash them later on, it'll merge them all together and it won't matter. And yeah, so you use git rebase auto squash, and all those fix-up commits become one. And then you push your changes to origin. And yeah, I have to repeat it again. Do not push fix-up commits to the origin, because fixing that is hell. Yeah, and if you need to fix that because you messed up, you look up git rebase interactive. That's how you would do that. So let's see this in action. All right, so we got a repository here. We'll make a change. Yep, so we add the file. We made our first commit here. Now we're making our second change. We add that. And here's where it's different. So here I am looking up the hash for a previous commit. Yes, and I do git commit fixup, and I type the hash. Now, one thing of note is that you have to type enough letters, but you don't have to type the whole thing. There you go. And we can see the fixup commit there. We'll do some more changes. I believe this time I am going to use the search thing. So we add the files, and we commit using a fixup commit. Yeah, and then we do the text search. And we can see how it adds like multiple fixup tags on it. And we're just going to rebase these all together with auto squash. And if we take another look, we'll see that it's down to just the one. This is how you keep things clean. That doesn't so much matter for your like personal projects, but if you're working professionally, don't make a mess. All right. So how do you delete a local branch? Well, it's git branch dash D, either small or caps, depending on if you want to ignore everything, and then whatever you're going to delete. Yeah, so small d will warn you if, and stop doing anything if there's unpushed content, whereas capital D will just be like, whatever. We don't care about that data. And yeah, like the slide says, this is kind of only used for feature branches. Your main branches, don't delete those. That's where your history is. All right, let's take a look at this. All right, we got some branches. Let's delete one. It's easy as that. All right. So very commonly when you're working professionally, you'll have all your work in tickets. A lot of times, each of those tickets will be in a different branch. At least they should be. Over time, you will collect a lot of branches on your local computer, and most of them will not be relevant anymore. So how do you get rid of them? Well, we do a few chains of commands here. So first, it's git branch, and that is chained to filtering based on trunk, which essentially is show everything that's not trunk. And then you pass it to git branch delete. Xargs makes it so that large lists of things work better. Yeah, I mean, you shouldn't be doing this unless you know that you're going to delete stuff. So take backups. Let's see it in action. Hey, look, a bunch of branches. So we type the command from earlier. A whole bunch of branches are deleted, but not main. And we're back to a clean slate. All right. So yeah, broke a file. How do you get an old copy? Well, first you find the commit where the file was good. So either use your forge or git log and look through that. And then you bring a file out from the past, which is just git checkout, the hash that you found earlier, 2 hyphens, and then the path that you want to, of the file that you want to bring back. Yeah. So here's a file. We'll put something inside of it. We'll add this file. We make a change to it. Turns out this change was not what we wanted, but we'll save it anyways. We get the commit hash for the first one, where the file was good. And we can see it's the new file. Here we're going to pull out the old one. So git checkout. I paste in that hash. Accidentally put it twice, so I'll do it again. I'm just going to type the first few letters. Bam. You have the old file out. So yeah, getting a file out of the past is super easy. All right. So maybe it's not just a file, but an entire feature was bad. How do you fix that? Well, provided that you squashed everything properly into one commit per feature or feature change, it's pretty easy. If you didn't follow those policies, well, that's a waste of time. So yeah, you find the hash of what you want to revert, and then you do git revert the hash. Then you commit it. It's very easy if you do things right, if you follow good form. Yeah, everything I said already. All right, let's see it in action. All right. So let's make some stuff for our demonstration here. All right. We're now going to revert number 1, I believe. Of course, you're putting it in with a hash. Yep. So it wants to prompt you to create a commit message for that. And I don't think you have to enter in this again. Yeah, exactly. But it should be changed. Yeah, so now the adding of file 1 never happened. All right. So say you got a feature request. You did some work, and you committed it, and well, darn, you put it onto the main trunk. Well, what you would want to do is revert that and apply all those changes to a new one. But you don't want to lose your work. How do you fix that? Well, you make a new branch from the main trunk. So you have to be in main, you make your new feature branch, and then you are going to remove that commit that you did on the main branch. So I would just look this up because it's hard to remember, but it's just git reset, head in all capitals, tilde, space, hyphen, hyphen, hard. That removes that last one from trunk. But you got to make sure that you branch it first so you still have access to your new changes. And then, of course, at the end, you check out your new feature branch. I mean, when this happens, you're not happy about it. Let's see this in action. So here's our branches. There's just trunk. Oh boy, we're working on some changes. We're going to commit those to trunk accidentally. Yeah. And now we are going to put those in a feature branch where they're supposed to be. Here I'm mistyping the branch name a bunch of times. There we go. And if we go back to the main, we should see that it's not there anymore. Yeah, nothing in the world, but if you didn't know this, you'd be a bit panicked on how to fix it. All right, something simple now. You typoed in your commit message. It's super easy. If you do an amend commit, you can just re-edit it. Very easy. Here's it shown. Yeah, nothing to it. All right. So say you made an error or one more thing for that last commit that you worked on. How do you do that? Well, it's kind of obvious from the last one, but you can do an amend commit. So you add the file, you do amend commit. Really easy. Yeah, so you just add the new files, and then you do an amend commit. Yeah, the no edit just makes it so it doesn't pull up the message to change the commit message. Done. Very easy. And that's all that I prepared for slides. There was so much more. In the book that I did, I have tons of stuff about like other kinds of repository types, having sub-repositories, which you should never use, but I do write about it and show you some recipes on that because other people have mistakenly used those. It's not hard, and once you start using version control, you'll find it hard not to use version control for basically everything. So use it. Go grab the book for reference. All right. So yeah, thank you so much for being here and listening to me talk about Git for far too long. Y'all have a good day.